Hey everyone, good afternoon. My name is Kumar Dubey. Thank you for such a wonderful introduction. Let me quickly take you on a journey on how we build Ask Clari with RAG. To do that, here with me, I have Rohan, one of our senior AI engineer, who has, with his experience, built this product for Clari. Coming back to explain what Clari does, Clari is a SaaS-based platform for revenue teams to collaborate on revenue process. Two things to unpack here. Revenue teams. So the core revenue teams such as sales, marketing, finance, or any other team which directly or indirectly contributes to the revenue process. Now, I'm very carefully using the word revenue process. Revenue is not just a number that you display at the end of the quarter or at the end of the year. Revenue is an entire process. So, to understand revenue process, let me give you an example. So, as I said, Clari is a B2B company, right? So, we'll have to, for our example, we'll have to set up a business so that we can interact with other business. For that, I'll use Rohan as an example. Let's say Rohan is starting a new business. What business you want to start, Rohan? Let's say Rohan is starting a business of water, packaged water bottle, right? Rohan wants to ensure that all the other company who has offices in Bangalore, they have a good supply chain of pure packaged drinking water for their offices, canteens, meeting rooms, etc. So Rohan, to do this, what he needs to do? He needs to start with cold emails. We all get those, right? So he needs to start generating leads, then find the right person where the leads could be converted, give demo after demo, and finally he'll find a person who will accept his services. Then he'll go into the pricing discussion. He wants to sell it for $3 per bottle. They want to buy for $2 per bottle, and then 1 cent here, 1 cent there. After a lot of negotiation, he'll finally close the deal, right? In sales, in a B2B sale, this is what is called. Okay, so coming back, this is the sales process that I was talking about. Right from lead generation to finally closing the deal. In sales term, this is called sales cycle. And when a company A provide a certain service or a software to company B in the defined termed and pricing, that is what we call it a deal. I'm just going into these details because the problem statement that we want to explain will use this detail. And to do all this, to achieve the entire cycle, you need to have bunch of conversation, whether through email, phone calls, video calls, because this is not like a day's work. This is roughly sort of will take few months to achieve. So what Clari does is provide a suite of product to for the entire sales workflow and revenue process. Once the deal is closed, you have renewal, expansion, that sort of a workflow as well, right? So to achieve that, Clari has built integrations over CRM such as Salesforce, calendar, dialer calls, video calls like Zoom and all, right? And we have a product called Copilot which joins your calls, dialer or video, and then it records the call and transcribed it. So not just the data that the sales agent will enter in their Salesforce or any other CRM tool, we also have the data that is collected from their conversation. And all this data is stored in our proprietary database called RevAI. Now, the entire shoot is really long. I'm not going to go in detail of all of them. I am going to focus on the layer that is built on top of RevDB, which is RevAI. This is where we have primary contribution in Clari, right? So we use this data, some data which are structured, which is like CRM field. You can imagine it as a CSV file, and some are unstructured, like I said, call, transcript, and email. There is no structure on how someone will write an email or how they will discuss something over a call, right? So we take all this structure and unstructured data and we generate meaningful insights so that the the company can take required action on that insights. One of such use case for RevAI was Ask Clari. What is Ask Clari? Ask Clari is a Ask Me Anything use case. So I'll go back to my example that I used. Rohan has set up a business. He's making deal after deal, supplying packaged bottled drinking water to different companies, now all across India. He has, let's say, thousands of deals going on with hundreds of companies, right? Now he wants to know, someone suddenly sort of reached out to him on LinkedIn or somewhere saying, I am in a contract with you and this is where my deal is stuck. Now he wants to know in that particular deal what is happening. Does he remember everything by memory? No. No. Now Rohan is a big person. He won't remember every detail, right? So he'll ask someone, right? And that person will ask someone else. And so finally they'll reach to the right sales representative who knows what is happening. But that guy is also dealing with multiple other clients, other deals. So he would also not remember everything by heart. Whatever response that he provides or whatever response that finally surface up will not be completely accurate and definitely will not come on time, right? So what you need is a AI assistant, an assistant which can analyze everything that has happened in a deal or maybe for the entire company. What do I mean by analyze the data in a deal? What data are we talking about here? Like I said, when a company A sells a software or a service to company B, that is what we call a deal. And in that deal, there is a lot of activity that happens. Example, emails, messages, calls. So when essentially this AI assistant is trying to search the answer of a particular question, it is going through all the calls, all the emails, all the conversation that has happened for that deal and trying to find the right answer. And this will be accurate as well as this will come within a minute or so, right? So that is what Ask Clari was. Empowering sales team by providing quick and accurate answer for a specific question related to a deal or an account. How do we achieve this? Before we go into how, I would like to show you a working example of how this functions. I would encourage you to focus on the right side. That is where we have the chat bot, where a question will be asked and it will go through every conversation for that particular deal and find the answer. And it will happen quick, so pay attention. So on the right side, we are searching, give me 3 key pain points that has been discussed in this particular deal. Now, you see there are 3 key pain points which got displayed. I think, as I said, it will happen very quickly, so maybe one more time. This is, by the way, the Clari UI where you have all the opportunity for a particular, all the deal for a particular company. And we have selected one deal, and in that deal, the sales guy, or let's say in our example, Rohan is trying to find 3 pain points because someone reached out to him on LinkedIn that their deal is stuck. And now he has actionable data that these are the 3 pain points where the deal is stuck. Now he can take right action, right? So this is how we are using AI to solve one of the use cases. How we are doing this, right? I think very simply, if we think, we have like the exact answer how this is being done. LLMs. We are using LLMs in our day-to-day life to ask question and get answer. And LLMs are good. Anything that you ask, they are able to give you the answer, right? One such example is ChatGPT, obviously, but you can use any LLM, ask any question, and you get any information, right? So we also thought maybe we can use LLM and get this solved, but we quickly figured out there are certain limitations to using LLMs. One of the limitation is latency. Chain of thought models or reasoning model LLMs take some time to find the answer. But we were okay with it because anything within 1 minute is still much better than the traditional method of finding answer for a deal. The other was the context. Every LLM is trained on a certain data. So if you ask a model, they will maybe train till October of 24. So anything that has happened after October, they don't know. And obviously they don't have the proprietary information, the calls, the deal, the conversation that I was talking about for a deal. And rightly they should not have. Those are protected information. And accuracy also is a problem. So though LLMs are really good, they tend to hallucinate quite a bit. So now, if not LLM, how do we solve this? To do that, I'll invite Rohan to take things forward and close how we solved Ask Clari.
Thanks, Raj, for sharing the context about what we do in Clari, and also sharing why this feature is needed and what this feature is about, and how we could model our solution around LLMs. I also want to touch on this point of context. This is something that we do not have readily available to the LLM, but this is something that we have in our suite of products, because we end up recording these calls, and we also have the textual data that is behind these calls. Also, when I say I'm asking a question on a deal, I'm inherently asking a question on these 40 to 50 calls that have happened in that deal, because these calls will have the source truth and these calls will have the answer to the question. Now moving on. So naturally we started evaluating what a normal RAG would look like. So if some people who do not know about what RAG is, let's suppose there's some sort of retrieval mechanism which lets me extract the relevant context that is associated to a question and augment it into my prompt and generate an answer. So those are the 3 steps there: retrieval, augmented, generation. And if I were to, if I had some sort of magical retrieval mechanism that was readily available to me, the only challenge that I need to figure out is what will LLM respond with and without context. So this is a simple question that I asked it. Why did Jack push this lead? And it started hallucinating because it does not have context. It pointed out very clearly that I don't have the context to answer this question, and maybe he pushed the sled for the so and so reasons. Now with context, highlighted in blue, I've attached a snippet of a story about which I was asking, and LLM does a recent job at reasoning the motives behind Jack pushing the sled. It points out that Jack thinks there's a treasure on top of the hill and he'll need a sled to carry it back. So context injection actually helped us here, but now there's one challenge that I still need to solve. How do I solve for retrieval? Before I get into that, I'd like to introduce this concept of embeddings for the people who don't know about it. So what is embedding? Embedding is an algorithm that we use to convert textual data into a numeric representation, mostly a vector. Just for simple understanding, these vectors are thousands of dimensions long and we cannot imagine that space. Just for simplicity, let's think of a 3D space. Here, you can see the 4 words on the left: man, woman, king, and queen. These were mapped using those algorithms on this 3D space. And when we took a difference between man and woman, the vector lines up in the same direction and almost in a similar magnitude as well. And what researchers came to decipher about this was that embeddings are able to store some sort of semantic meaning behind these words, and we can navigate these relationships. So verb tense is also there. Again, a similar lineup. Country and capital, again a similar lineup. We'll take this one step forward. What happens when we start embedding sentences? So the 4 examples on the top: a little boy is walking, a sad boy is walking, look at my little cat, look how sad my cat is. So there is a drop-in replacement of sad on the word little. And you can see how it almost seems like magic, how it lines the vector in a direction that's similar in both the cases. So we're talking about the subject, one is boy, one is cat, and we're injecting that sad, placing a drop-in replacement of sad on little. Just to take one more step forward. They did this. So on the bottom right, in light red color, you can see there are 2 questions. What is your age and how old are you? They have a similarity of greater than 0.8. And there's a semantic similarity. So now maybe some sort of semantic based retrieval mechanism might be brewing in your heads. Basically, the question that we asked, what are the pain points in the deal? So those 2 words, pain points, and there might be certain chunks within those series of 40 to 50 calls, maybe in call number 21 and call number 23, around 20 minutes or 30 minutes, pain points were indeed discussed. So there will be some sort of semantic similarity there. And that is the context that we need to inject. First, I'll explain what a basic RAG pipeline looks like and how we are different from it. A basic RAG pipeline has 2 components. One is ingestion, where you take all your documents, chunk them, embed them, the embedding model that I explained a while back. And then you stuff all of this up in a vector DB, which gives you the capability of querying, basically doing the semantic similarity. Other component is obviously the part that we showed in our demo as well, where a user asked a query, we embedded it, we searched our vector space, and we came up with those chunks or basically those segments of call where that pain point was mentioned, and we augmented that context into our prompt and got the response. But that's what a typical RAG pipeline would look like. We as a company, we're 10 years old. We deal with millions of call documents. I cannot go and embed all of that just for this one feature. It does not justify. So maybe investing into a vector DB is not the prudent choice. And also I know that's not the norm, but we wanted to evaluate from first principle. Is it the most prudent choice for us? So these are the four things on which we tried to evaluate vector DB for our use case. Most of these are interconnected. So we already have a data store of NoSQL and SQL, and then we want to introduce one more data store, so we need to explain everyone why we need this data store, and we'll have to pay a cost for it. Then there's maintenance overhead. Being a big company, we'll have some sort of DevOps teams or a security team that'll look after this. Then the rest of the 2 points, let me talk in more depth. Ever-changing embedding landscape. Every morning I wake up, there's a new embedding model which is better than the one that I'm using in my project, and maybe I need to shift to that. I cannot, just keep on changing my embedding model every day. So the landscape is not mature and it has not plateaued yet. So there's always a new model that you can use. And also the amount of data that we deal with, it's terabytes of data. For instance, if there's 1 TB of data that we embed, and if there are 5 different embedding models that we have used till now, we end up with 5 TB of data. That's a lot, if you ask me, and I'll have to justify this cost. Usage metrics. Now, in some of our features, we observed that a sales representative only asks in 5% of the calls, he asks a follow-up question. What does that mean? Out of 100 calls that he has attended, he's asking question on only 5 of them. So if I were to take the example of a typical RAG, where I embed all the millions of call document I have, 95% of the compute and the cost I'm paying will go to waste. And I don't know what the usage pattern here is. I know the metric, but I don't know the pattern. So being engineers, just for fun, we wanted to do a cost comparison between a vector store and a blob store. I know vector store is made, vector store supports querying semantic similarity, and a blob store wouldn't give you that, but just for fun we did that. And we found that S3 is 10x cheaper. And at this point, there was some sort of solution that started to brew in our heads. So before I go to the next slide, I'd like to talk about our approach for RAG. So those two yellow boxes that you saw earlier, we wanted to replace that with S3. So instead of storing all our data into a vector store, which is much costlier, we wanted to store it in an S3 store. And instead of querying a vector store, in our case, we only need to answer a question on a deal, which has only 40 to 50 calls. So out of all the calls that we have in S3, we'll take a small segment out of it, the relevant 40 to 50 calls. We'll chunk, embed them in memory, and using a library called FAS, which is developed by folks in Meta, we'll index those embeddings and get the relevant context. Sorry. Yeah, so that was our approach. All of this is happening under one instance. So you can see the call documents flow and how we want to cache the chunks and the embeddings, and we do in memory search, and we only invoke this for 5% of the questions that are being asked for. So I'm doing that 5% of a job on compute as well, and I'm saving 95% now. I'm not having to pay for embedding all the data across all my calls, across all the customers. So what will a first pass of this pipeline look like? By first pass, I mean very first question that you're asking. What will happen is you'll take all those 40, 50 calls, chunk them, upload them, embed them, upload them, retrieve it in memory, retrieve the correct, the chunks that are matching your question, and in that case, the pain point question. So there might be some top key results we get there, augment it into our prompt and generate the answer. So this is a 7-step first pass. What will happen in the second pass? This is where it gets interesting. In second pass, as you noticed, I'm skipping the first 3 steps. Why? Because I've already embedded it once. Why do I need to embed it again? Why do I need to pay for that cost? So I'll just retrieve it from S3, index it in memory, and then retrieve the relevant chunks, augment it into my prompt, and get the answer. So every successive pass is faster. As you saw, there's a lot of upload, download, and indexing happening, and also embedding happening. So just on paper, it seems fine, but we need to run some benchmarks so that we can, really commit to this. So that's what we did. With S3, we saw the upload times to be growing linearly and at a very lower slope. So as I pointed out, a call typically has like around 40 to 50 calls. A deal has typically 40 to 50 calls in it. I took a worst case. What if it has 320 calls? Each of those calls 1 hour long. Each of those calls having 10,000 words to embed. How long will it take to upload it into S3? At max around 9 seconds. Base case you can see like around 1 second. How long will it take to download it? Because in our second pass we are downloading it. We're not uploading it. At max it goes to 4.8. Again a linear relation that we observed here. And then, as I pointed out, I'm indexing those 40, 50 calls in memory. How long will that take? Again, in worst case, around 4 seconds, 3.5 seconds, in fact. The last bit, embedding. In order to create embedding for one call, which has around 10,000 words into 364 dimensionality. I mentioned 3 dimensions in my example for embeddings. Actually, it is a lot less to capture the meaning behind the sentence. You need around like roughly 300 plus. 500 I think is the best, in terms of speed and accuracy. So we did this experiment with 364 dimensionality, and we used Ray here. You can look that up. It's a distributed computing library, and we found that it takes around 1 second. Now we sat to calculate what will happen in the worst case. So for 320 calls, it will take 320 seconds to embed. But if I spin up 10 clusters of my this array actors, it'll take divide by 10. So 32 seconds there. 9 seconds to upload, 4 seconds to index. You roughly end up about at 45 seconds. You have 15 seconds to speak to the LLM, chunk the calls and all the other things. So it was a safe estimate that up to 300 calls, each having up to 10K words, 1 hour of data, we could answer within a minute. And that's first pass. Second pass, as you saw in the example itself that Raj played out, it was fast. Yeah, so now I'll again ask Raj to talk about the key takeaways here.
Thanks, Rohan. So yeah, I think it's okay. You can. Yeah. So key takeaway for us was sometimes the traditional answer is not the one that you should go with. Traditionally, building a RAG would have been costly. We would have had to start maintaining on another database, which required another team and all those sort of a thing. What we ended up choosing was a very innovative solution. We said we will break the problem. We will not use VectorDB for storage and retrieval. We'll break it and use S3 for storage, and we'll have in-memory index for retrieval. That way it will be faster. It will scale fast. I can practically sort of have so many calls, like Rohan said in his metrics. And plus, it's cheaper. So we all like it. We all like not to spend money. So yeah, that's the key takeaway that I want you to take up with. Generally, if you start building with AI, you will find a traditional solution. Don't stop there. Look for innovative way to use that. There are few things that we would want to improve in the solution that we presented. I'll not go detail in each of the point. I'll just give you one example. The first version, when we rolled out, and the internal testing was happening. They were asking bunch of questions like pain points, key takeaways, next step, next steps, action item, and the answers were coming almost how we wanted it to. But someone made a mistake and just typed HI, and they wanted to type something else, just did HIS and entered. And since we are doing semantic search, like Rohan explained, HIS, somewhere in the call there will be word HIS or history or something else which matched, and the LLM found some context, the RAG found some context, the LLM generated some answer. So even if there was not a real question that was asked, since there was a context matched, the LLM had some context and it generated an answer, right? So one of the improvement that here we need to do, and for any traditional RAG solution you need to do, is rephrase your query so that it is better suited, and the context that you search are more accurate. Similarly, some chunking improvement we can do, and along with embedding search, we should also do keyword based search. Sometimes the answer is directly in front of our eye. Matching the words from the question will directly help. We don't need to do semantic search. So these are some improvement that we have thought of. Any question? Again, it's lunch time, so I know we all want to go. These are our LinkedIn profile. If you want to talk to us more, do check that out. And I quickly want to flash about few facts about Clari. Clari is a bit 11 years old, but a bit mature, but a very young organization. It has engineering set up in 3 different continents, in US, in Poland, and India. In India, we focus on building platforms and AI frameworks, services, features, and we are growing rapidly. So anyone interested, please find Rohan. Thank you, everyone. Thank you for your time. Have a good day.